Hello all, welcome to Public Cloud Design Tips and Tricks again. As a part of design pattern, today's topic is circuit breaker pattern. The problem statement is how to keep a leaf multiple components interaction in a distributed environment. Now, before we jump into the details of circuit breaker, let's have a discussion about why circuit breaker and what is circuit breaker. So let's have a general example from our day-to-day life is at our home. A circuit breaker is always a switch to protect any electrical abnormality. It protects from overload or any short circuit scenario. Now, the idea is to stop current flow temporarily and to protect electrical appliances in case of a surprise or in case of a failure. Now, this pattern works to stop request and response process for a while if any downstream service is not working for a while. Okay, so that is why circuit breaker is actually. So in a general example, if you see the diagram, there are three services running behind service 1, 2 and 3, and there is a load balancer in front of those services to send the request. So circuit breaker always sits in front of the load balancer, or it always works as a proxy to deal with the client applications. Okay. So how to deal with that? Let's have a discussion in the subsequent slide. Now the way of working of a circuit breaker pattern. So let's discuss about how does it work. Okay. So now in a normal scenario, a client always sends data to backend system to get the response. Now let's say for an instance, one of the backend stops working due to some failure. Okay. So what will happen? The consumer is not aware of the health of the backend service. Okay, the client applications. Now, as a result of that, it keeps sending requests to the backends even after a failure happens. Okay, so the request gets piling up continuously. Okay, and it resulting in a network choking. Okay, now in this kind of a scenario, how a circuit breaker works, it works as a proxy to handle client requests. Okay, now what it will do, it will stop sending the request to offline services for a specific moment. Okay, and that specific moment is called threshold here, and after a threshold it starts sending a limited request for validations. And okay, so that particular that particular threshold window or threshold time, that will always give the backend services a sufficient window to come back. Okay, so that is how a circuit breaker works actually. Okay, now let's discuss about two different use cases. Okay, so the first use case, if you can see, there are four services running behind. Okay, so these are the four downstream services, and now there is a load balancer who is actually responsible to send the request to the downstream services. So here you can have a HTTP server also as a load balancer. Okay, so now let's say there is a situation where service 1 fails to run. Okay, so it's not responding, for example, and at the same time service 1 is also more demanding. Okay, so the client applications are requesting more and more requests to service 1. Okay, now what will happen? Let's say the service 1 is not working and there are more requests coming to the load balancer. Then it will the load balancer will keep on creating threads. Okay, lots of threads for each request. Okay, so now the threads are getting piling up and service 1 is not responding. Okay, so what will happen in this kind of a scenario? It results in blocking other threads as well to consume the same service and other service as well. So if you can see here, the red threads which is consuming service 1, that keeps piling, and at the same time, because service 1 is not running, the other threads, the blue threads, who are actually responsible to access to different other services like 2, 3 and 4, they will also becoming slowing down and start choking. Okay, so that is one scenario. In the use case 2, it's a different kind of scenario than use case 1. Is, let's say there is a situation where you have a lot of backend services service A, B, C, service 2, 3, 4. Okay. But the operating model of service A, B, and C's are more a chain structure. So what it means, service A depends on service B and service B depends on service C. So in a way, when service A starts, it it's send a request to B, and based service B sends a request to service C, and based on this response of service C, service B, and service A respectively, they will provide a response to the client applications. So now let's say in this case, somehow service C is not responding, or there is a failure happen at service C level. Okay. So after some time, when service C starts sending a request to service C and it's not getting a response, then it also starts not responding. Okay. And that ripple effects will come to service A as well. Okay. So in a nutshell, service A, B, and C after some time, starts failing to provide a response. Okay. So in this case also, the threads that gets created by the load balancer for subsequent request gets piled up. Okay. So same situation arises as use case one. So the threads that gets created to consume service A will start piling up, and that creates a ripple effect of other threads as well. So it's more a checking scenario, choking scenario. Okay. So you can say, like, assume a service chain is established here. A depends on B. We have already discussed B depends on C and service C fails to respond. Now service B keeps waiting, and that leads to service A keeps on waiting. That's a ripple effect, and that's also results in request piling up. Okay, and system never gets recovered back. So this is another typical scenario where you will get a choking scenario. Now, what is a circuit breaker here and how it solves the problem? So, a circuit breaker always works as a proxy. We have already discussed, and it can be implemented as a state machine. Okay. Now, ideally, there are three states that gets created in a circuit breaker, and those are closed state, open state, and half open state. Now, let's discuss about how the states works. So, it starts with a closed state. So what is a closed state? When all the backend services works normally and the request response paradigms works perfectly fine. So that is called closed state. Now let's say there is a failure happen on the backend services. Okay, so when there is a failure happens and that failure exceeds a time limit. Okay, so that is called the threshold limits. Okay, so what will happen? The backend services will keep on requesting to the client application keeps on requesting the backend services, and backend services will not provide any response, or there is a failure for a certain limit of time, then your open state starts created. Okay, so that is called open state. So after a failure, after a certain time or the threshold time, let's say the failure still continues, then the open state starts. Okay. Now, the once the open state starts, okay, then what will happen? The circuit breaker will stop sending requests to the backend service, and instead, for that particular time, it will start sending error message to the client, okay, or the client application. Okay. Now, within that period, the circuit breaker will give enough time to the backend service to retrieve back, and after retrieve back, okay, it starts validating whether it has started working or not, the backend service. And and let's say it started working. Okay, then that particular period or that particular state is called half open state. Okay, so half open state allow limited requests to pass through from a circuit breaker to the backend systems. And if everything goes well in that half open state, okay, let's say for some times, so basically you can divide total failure time into, let's say, time 1 and time 2. Time 1 is more about validating whether the backend service again starts back or not, that is the half open state. And once that validation is successful, time 2 is more about creating the again the closed state. So it starts getting successful request from the backend services, and then it slowly the circuit breaker starts sending all the requests to the backend service. So then it will achieve the closed state again. Okay, so basically it always travels through a open state, is the full failure state. Then half open state, it's the half failure. It gives enough window to the backend service to retrieve it. And once everything finds, then again it's come to a closed state. So that is how the life cycle works and the state machines work. Okay. So in a nutshell, circuit breaker helps to enhance the user experience more seamlessly and also provides backend system an opportunity to heal back to a normal state. So that is how a circuit breaker works. If you still want to go more into it and deep more, will do a deep dive more into it, you can always refer a Microsoft link to know more about it. Okay. Thank you and have a good day.